With the name of Allah Almighty, dear students and all the viewers, may peace be upon all of you. I am Dr. Engineer Majid Amin, subject specialist, mathematics from Peshawar, Pakistan, and I welcome you to my YouTube channel, Maths.Physics. We have started this course, 9th class mathematics. Chapter is matrices, and today we will have its 4th lecture. We have already delivered 3 lectures, and these are the links, or otherwise the whole playlist is in the description. You may go from there. Today we are going to discuss this topic of this chapter, addition of matrices. How to add two matrices, like we add two numbers. We say 4 plus 2 is equal to 6, minus 4 plus 2 is equal to minus 2. Likewise, how we will add two matrices. So let's begin our lecture. I write the simple two statements. All right, students, what did I write? The statements are two matrices A and B. Suppose A and B are the matrices. They are said to be conformable for addition, or fit for addition, or suitable for addition, or their addition will be possible if they have the same sizes. Means that if we can add two matrices if and only if they have the same sizes. If somebody tells me what will be the answer of these two, and it means add them, so I will say, since it is 2 by 2 matrix, it is 2 by 3 matrix having 2 rows and 3 columns, it is not possible because they have different sizes. I have given you the idea of size in the previous lectures. It has size 2 by 2, it has size 2 by 3. We can't add two matrices having different sizes. This is the condition that they must have the same size. For example, I am given these two matrices. For example, students, two matrices are given and they have the same size, and he says find A plus B. Add A and B. So the size of matrix A is 2 by 3 having 2 rows and 3 columns. Similarly, the size of B matrix is 2 by 3 as well. Then they are fit for addition, conformable for addition, suitable for addition, and I say that C is equal to A plus B. And if you add A and B, if they're same sizes, we can add them. And if we add them, we will have a new matrix C. This C will be obtained by adding the corresponding elements of the two matrices corresponding, having the same position. Like the corresponding element of the corresponding, this is element of first row and first column. So this is the element of first row and first column. So we say that these two elements are corresponding elements. Hence, C is equal to A plus B. Write the two matrices 2, 1, 6, minus 9, 4, 7, plus 0.5, 3, 8, minus 1, minus 4. Okay, now add their corresponding elements. Students, we will add these two, 2 plus 0, these two, 1 plus 0.5, corresponding 6 plus 3. Right, students? Minus 9 plus 8, 4 plus minus 1, 4 plus minus 1, 7 plus minus 4, 7 plus minus 4. Hopefully, it is within the range of the camera. Yes, it is. So, if you simplify, you get 2, 1.5, 9, add them, minus 1, 3, and 3. This is how we will add two matrices. Generally, we say that Aij plus Bij elements of matrix C will be, Cij will be equal to, for example, this is which element? This is now element of matrix C. The elements of matrix C is represented C11, C12, C13, and so on. This is which element? A11. This is A12. This is A13. A13. This is B11, B12. B13. If you are confused in these terminologies, it means you have not gone through the previous lectures. You have to go through them. Now, what is C11? C11 is equal to A11 plus B11. It is called adding of the corresponding elements. Each element of matrix C will be obtained the corresponding, by adding the corresponding elements of the two matrices. Here A11 is 2, B11 is 0, it is equal to 2. C12 will be equal to A12, B12, A12 is 1, B12 is 0.5, you got 1.5, it is. Okay, students, now next condition. If two matrices have the same sizes, so we can add them. Of course, we can add them, and the resultant matrix will have the same size. For example, if we have matrix A, matrix B, its size is m by n, m rows, n columns, B, m cross n. By adding them, we will get a new matrix. Its size will be also m by n. Hopefully, it is clear to you, addition of matrices. Likewise, we have subtraction of matrices, but it is very simple. I will just go through it. Subtraction of matrices. If they are conformable for subtraction, if they have the same sizes, and A minus B is obtained by subtracting the corresponding elements of A and B. For example, A minus B, A minus B. So here you will have to subtract the elements. 2 minus 0, 1 minus 0.5, 6 minus 3. Just replace addition by subtraction, my sweet students. 2 minus 0 is 2, 1 minus 0.5 is 0.5. Students, this is 3, it is 11, 7 plus 4 is 11, it is 5. The other one is minus 70. Subtraction minus. So Cij is Aij minus Bij. The same, no need to explain further. I think the same thing, just replace addition by subtraction. Right, students? All right, students, let's discuss these two topics. Commutative law of addition, associative law of addition. We say commutative, but we Pakistanis, we say commutative. Commutative law of addition and associative law of addition. Like in numbers, you say that A plus B will be always equal to B plus A. It is commutative law of addition. It simply means that if A and B are two numbers, if I give you two numbers like 9 and 3, and I want you to add them, so you should not ask, sir, which number should be taken first. This law simply means that if you take 9 first and 3 second, or if you take 3 first and 9 second, in both cases, you get the same results. It is called commutative law of addition. Same is the case in matrices, and matrices A plus B will be always equal to B plus A if they are conformable for addition. The same sizes, but it doesn't matter which matrix you take first. For example, you are given these two matrices, 4, 2, minus 1, 9, 6, 3. Understand? This is another matrix. 5, 1, 10, 0, minus 8, minus 2. One student comes and he determines A plus B. There's another student who comes and he calculates B plus A. We are sure that they will get the same results. Just he will take matrix A first and followed by matrix B. Now I assume you know how to add two matrices means their corresponding elements, so I will skip that step. 4 plus 5 is 9, 2 plus 1 is 3, 6 plus 10 is 16. Minus 1 plus 0 is minus 1. This is 1, 3, or 3 plus minus 2 is 1. Hopefully it is clear to you. Now the second guy, B plus A, just taking B first and matrix A second, it will make no difference in your answer. Minus 1, 9, 3. Here we had 4 plus 5, and here we have 5 plus 4. You see, students, you will get 9, 3, 16. I will just write from there. Okay, minus 2 plus 3 is 1. In both cases, you see, you have the same results. Then you have to write from 1 into it is clear. From 1 into it is clear that commutative law of addition is satisfied. Or a plus b is equal to b plus a. And of course, in subtraction, there is no commutative law. A minus b is never equal to b minus a. Like 9 minus 3 and 3 minus 9 are not equal. Commutative law doesn't hold in numbers. Same is the case in matrices. Well, for subtraction operation, it holds for multiplication, but multiplication is our next topic. Right, students? It is called commutative law of addition. Similarly, associative law of addition. Students, what is associative law of addition? For numbers, there are three numbers: a plus b plus c, a plus b plus c. If you calculate b plus c first, and later on a, or a plus b first, later on c, in both cases, you will have the same results. And same is the case for matrices as well. First, if you determine b plus c, then add with a, or you first add a and b, then c. For a, b, c, three matrices having the same sizes. Let's have an example for that. Example, and to make it simple, I will take 2 by 2 matrices. Students, 3, 1, minus 4, 6. This is matrix B. Students, 5, 0, 7, 8. This is matrix C. 10, minus 1, 0 0.3. And for example, 6. Okay, first you determine left hand side. For that, first you do B plus C, simply putting the numbers. Nothing could be more simpler for you, my dear students. 5 plus 10, 15, minus 1, 7.3, and 14. B plus C. Now you find A plus B plus C. Students, A is 3, 1, 4, 6. B plus C 15, minus 1, 7.3, 14. Add them. 3 plus 15, 18. 1 plus minus 1, 0. 4 plus 7.3, 11.3. 6 plus 14, 20. This is your left hand side. Now, right hand side. Right hand side, students. First find A plus B. A plus B. A is 3, 1, minus 4, 6. B is 5, 0, 7, 8. Add them. 8, 1, 3, 6 plus 8 is 14. This is A plus B. Then, of course, we will add C. A plus B is this matrix, 8, 1, 3, 14. C is that one. C is 10, minus 1, 0 0.36. Right, students? Add them. 18, 0, 11.3. A plus B. I think we have committed some mistake. B plus C. B plus C. Now A here we have minus sign. So it will be 3.3. 3.3. Here it is 3 plus 0 0.3 is 3.3. 14 plus 6 is 20. Then you say that from 1 into it is clear. From 1 into it is verified. We say the law is verified. Not proved, the law is verified. A plus B plus C is equal to A plus B plus C, or associative law of addition is satisfied. Dear students, let's discuss another topic called additive identity, then additive inverse. All right, students, additive identity. Identity, not that identity of English, which means for identification, some for recognizing. Here, identity means in mathematics, identity means having no effect. Having no effect in the given operation means that will not change the other thing. For example, for numbers, if you say if I add 1 with 4, it will change this number. Automatically, it will also change, but you get some new result. So it is not identity. But if you add 0 with 4, you get 4 0, x plus 0 is equal to x. Addition of 0 means nothing. It has no effect in addition. We say 0 is additive identity. Likewise, we say if a plus b is equal to a means if you add matrix B with matrix A and you get A, this matrix, then B is called additive identity. And my sweet students, of course, this will be a null matrix having the size of this matrix. For example, students, this is matrix A, this is matrix A, 2, 1, 9, 4. So what should be added with this matrix 8 again to get that matrix again? Of course, here we will have 0, 0, 0, 0. So we say null matrix is identity, additive identity, but having the same size. If you have this matrix over here, then the null matrix will have the size. This is 3 by 2, so the size is also 3 by 2. Null matrix having the size of the given matrix A will be called additive identity for that matrix A. And what is inverse? Additive inverse. Not inverse doesn't mean reciprocal, reciprocal, like the reciprocal of x, 1 by x. These are called reciprocals, not inverse. Additive inverse means that if A plus B is equal to additive identity, null matrix, what should be added with? So here we know that additive identity is a null matrix. So 0 null matrix minus B, A is equal to minus B. Then this B is called additive inverse of A. What should be added with the given matrix to get identity result? The matrix that you will add with the given matrix is called additive inverse of this one. Of course, this is additive inverse for this. These two are additive inverses of each other. For example, my sweet students, this is a matrix 4, 1, minus 9, 0. What should be added with this matrix to get a null matrix? To get a null matrix, the simple hint for this is change the sign. Because if you multiply minus with the given matrix, this minus will be multiplied with all the elements. So it will change the signs of all the elements, of course. So the matrix which should be added with this, it will have entries minus 4, minus 1, 9, and writing minus 0 or 0 makes no difference. This matrix is called additive inverse of the given matrix. And you know, if there is you come across the MCQ, what will be the additive inverse of a null matrix? Do you say the additive inverse null matrix is self-additive inverse? Null matrix additive inverse will be that matrix again. Additive inverse of the null matrix is that matrix again. So we say that null matrix is self-additive inverse. Hopefully it is clear to you, and I think it's enough for this lecture. And next lecture, God willing, we will discuss multiplication of two matrices. Hopefully this lecture is beneficial for you. Don't forget to share with your friends. Remember me in your prayers. and goodbye till next lecture.